Hello and welcome to another IBMS pod. In this month's episode, we speak to academic cardiologist Dr. Rameen Shakur about everything from football to which vice it's best to give up if you can only ditch one. Spoiler alert, it's smoking. After which, Francis Yongblah joins us for LabLife to discuss playing with the London Gay Symphony Orchestra and much, much more. But first up, as always, the news.
Welcome to this month's IBMS News. Biomedical Science Day was celebrated on the 24th of June and was our biggest year yet on social media, with a reach of 9.5 million people throughout the day. We were overjoyed to see the celebrations of the profession across the UK. Have a look at how the profession celebrated in our photo gallery on Facebook.
The winners of the At the Heart of Healthcare competitions for Biomedical Science Day had a record number of entries. Head online now to find out who won.
The IBMS has awarded 2 new honorary fellowships to Jill Rodney and Jane Mills. Jill recently retired from her position as Chief Executive of the IBMS after a decade in the role. Jane is currently head of program for COVID-19 testing with NHS England and Improvement.
At our annual general meeting last month, we announced the election of 4 new council members. Dr. Sarah Pitt and Tamina Hussain were elected as national members, while Angela Jean Francois was elected for London and Jennifer Collins for the North East. You can find out more about our new council members and all our other stories on our website.
So, welcome to Dr. Rameen Shakur, who is an academic cardiologist from MIT. So, welcome to the podcast, Rameen.
Thank you, Rob. Thanks for having me on the podcast.
Pleasure. So, could you say a few words of introduction, Rameen? Tell us a bit about your current role and what you do, please.
Yeah, so my background's in academic clinical cardiology initially, and moving more to the scientific side. We are sort of very strongly basic science related and work on 2 big areas of regenerative medicine and precision medicine within the umbrella of cardiovascular disease.
And you're an academic cardiologist. In what way did you bridge the gap between treatment and research and academia? What kind of position do you occupy on that spectrum?
So initially, when I was growing up, I went to medical school in the UK. And then having been through medical school, trained in general medicine. But throughout the whole course of that, I just very early on, even as a med student, got the research bug. So, having done researches in my bachelor's year, I was a Wellcome Trust studentship at the Sanger Center very early on. Then I did an MPhil on immunology. And then I finished off my clinical training. And so I've always really loved the basic sciences. And then the translation side was to see how that scientific discoveries and scientific questions really apply on the physiology of the body. And then when I went back into finishing off my clinical work, training in cardiology in London, I won a Wellcome Trust fellowship. And so I went back to Cambridge to do my PhD. And after that, the rest is really history, where it's just been carrying on with that sort of research, developing that work, developing sort of that group-led collaborative work.
And it's quite a timely moment to be talking to you with the football and Christian Erikson. Were you watching the football when that happened? Did you hear about it afterwards? Or?
Yeah, so I was watching the bit of the highlights, and I just saw on the news how they sort of stopped the video as he was going across for the ball, and I knew something was sort of not quite right. And then family and friends had sort of sent me the clips that they saw on TV at the time. Obviously, it was a very shocking viewing for everyone concerned. But you're absolutely right, Rob. That's our sort of main area of interest: sudden cardiac death, and sort of arrhythmias, and the whole promise of how do we understand the mechanism of something like this? Obviously, Christian Erikson had full medical tests when he was in Italy, where he plays, and prior to the games, they have strong medical teams. But the reality of the situation is, here's a very fit and active 29-year-old who suddenly collapsed, and he didn't know anything about it. He certainly had no previous history to say that this was going to come on. So it must be a great sort of distress to him and his family. But I would say the real strong point to come out of the whole episode is the amazing work of not just the medical team on the ground, but his fellow colleagues and sort of players who started doing CPR. And it goes back to the case where I actually saw similar clips with the Fabrice Muamba case going back about a few years back. He had no cardiac output for 70 minutes and lives to say that, lives to sort of see the whole thing. And you think about that, his downtime was about 15 minutes, Christian Erikson's.
How is it possible to survive with no cardiac activity for 70 minutes?
I would
just assume you die.
So this is the whole premise, that he, again, was, Fabrice Muamba was saved by the fact there was a cardiologist in the Tottenham Hotspur's fans area who came across, began CPR, and through the whole process, the heart, when it sort of stops or is not beating efficiently, goes through a stunning period. And what I presume is what they were keeping the CPR. It's a great efficient way of keeping circulation going, especially to the brain and major organs, to actually keep it going, where he was then stabilized in hospital. And it was a long recovery back for him, as you saw, for Fabrice Muamba, but it did mean the end of his career. What that means for Christian Erikson, I don't know. Certainly, the early tests, from what I've read, seems that they still haven't found a pure cause. But is exactly what we were interested. Our interest is on inherited heart diseases, muscle diseases of the heart, and these muscle diseases of the heart, called cardiomyopathies, are one of the leading causes of sudden cardiac death and irregular rhythms and heart failure. So it's not as rare as you think. We think it's roughly about 1 in 500 have this sort of mutation. But whether we see it or not clinically is something that is of active interest.
Myself and Jordan, who is also on the podcast with us today, both do a fair bit of running. Should we be running slowly and being concerned about pushing ourselves too far? Is this something where there are risk factors, or is it just one of these things where it's like there's nothing you can do, just get on with your life and hope you don't suddenly keel over one day?
Yeah, great question, Rob. I've had a lot of these sort of questions, people coming out and sort of emails. It is a sort of, these sort of episodes, especially global episodes like this, make you stop and think. And what I would say is there's nothing to change your lifestyle. It just means that you will be more cognizant and aware of your body. Now, what that means is the chances of this happening, like a Christian Erikson, remain extremely low for the majority of us. But the key point is, how do you know if it's going to happen? Because you're not got an ECG strapped to your chest. How do you know that when you're pushing yourself, that you're not pushing yourself to a certain level which could be harmful? We don't know. And it's common things being common. Most people will be fine. And it's that small minority of people who may have something hidden or sort of not really come to fray that's really of interest from a genetics perspective, or from especially another point of due to COVID, where we know COVID induces some arrhythmias, electrical changes, causes inflammation of the heart. And this is an area where we're all working to better understand our bodies now that we're sort of trying to get on top of the actual virus itself. So what I would say is, it's nothing to be alarmed about for the majority, but it certainly makes you think about to take your own body symptoms to heart. So if you're pushing yourself and then you think, am I getting a bit too much of a twinge continuously? Are you getting sort of something that you otherwise think, nothing to worry about? It may just focus your attention to understand that symptom, but I wouldn't get sort of worried or carried away with it, because I think for the majority of people, like I say, this will not be something that will affect them.
Yeah, and as an editor, I notice words wherever I go and kind of phrasing, bad phrasing, good phrasing. As someone who works in cardiology, are you constantly aware of what your heart is doing? And if so, does that drive you a little bit insane? Or are you able to ignore it?
Yeah, so you say, doctors and sort of clinicians and even scientists, they're good at prescribing the problems and telling people to do, but they're probably the worst to actually take heed of themselves. But it's interesting you say that point, actually, Rob, because when we talk about being aware of your own heart, we're only really aware of it when we push ourselves, right? So unless we're doing the next Olympic trials, you and I aren't really going to be seeing much difference in our normal exercise activity. But we should be cognizant, like when we go for walks or anything, it's not something that one comes to mind except when you are pushing yourself. So having a comparison, especially when you're running, which is great to hear, both of you doing that, you get a feel for what your body can cope with and what your mean and average is. So always thinking about that to say, what's different from today as it was yesterday is a good way of keeping track of how your body is actually talking to you.
Brilliant. And you mentioned cardiomyopathies earlier. That's some terminology that a lot of our readers won't be familiar with. Can you kind of flesh that out a bit more for us and what exactly they are?
So cardiomyopathies are the family of diseases which refer to the heart muscle. So the cardiomyopathy is enlargement of the heart muscle, which causes the normally efficient pumping capacity of the heart to reduce. And when you stretch out and you elongate the whole heart muscle, it also affects the electrical capacity of the heart to induce electrical problems like the ones we saw with Christian Erikson.
So we want to talk a little bit now about the paper and the research you've done looking at the genetic changes that can actually cause some of these cardiomyopathies. So, how did it come about in the first place? What did we know about genetic changes behind these inherited diseases beforehand?
So it's interesting. So my first introduction to the cardiomyopathies was as a sort of junior doctor. I was training in London and I saw these sort of inherited cardiac disease clinics. And the inherited heart disease clinics in a lot of these specialist hospitals are where you get clinical geneticists, cardiology clinicians, research teams all together. And then you have patients with their families. And what intrigued me was, due to the whole burgeoning field of sequencing and gene testing, we had an idea that certain people in their families have an increased risk than others in the population for enlargement of the heart without them to have any previous pathology. So what I mean by that is they haven't had a heart attack, they're otherwise being fit and well, but for some reason their heart enlarged much, much bigger than would be normal for you and I. So there was a pathology there without any sort of trigger. And that's how the field of inherited cardiology came about, where we knew that there wasn't sort of a inherent physiological attack coming from, say, a heart attack or oxygen, but we didn't quite understand why these patients were getting these anatomically enlarged hearts. And it was happening in fairly young age groups. For example, the commonest cause for people of sudden cardiac death in less than 35 is actually due to cardiomyopathy. It's the most commonest cause in the world. And that is because it was this sort of young age group of coming up from sort of the 25 plus age group, less than 35 age group, who would be otherwise fit and well, no previous cardiac problems. And we see these sort of patients coming in saying, look, I'm getting short of breath, can't walk as far as I could before. Nothing to do with the exercise. It's actually because when you look into the heart, when you do the sort of echocardiogram, you see massive changes there. This change got me interested to ask a very, very difficult question, which I think all scientists should ask. But when you have patients in front of you, they basically ask that question for you, which is, so what? Right? And it's the so what question, which I think fundamentally in a lot of basic science we forget to ask, but is the driving force for our curiosity. You can be curious about the science, and you can be curious about the pathology, the physiology, the molecular biology, all of which will increase our knowledge base. But the difference that I found was when I explained the sort of nuances and I understood a bit more about the molecular biology and the work that we were doing, when you go into ask to patients in the clinic, they're saying, yeah, that's great. This Nature paper is amazing. But so what for me? How is it going to actually affect me? What are the differences that it will make to treatment for me? And that's a very, very humbling point. And what I then started to look at was, well, that's a very valid point. And it's all well and good saying that we know the structural biology to an extent. But what was interesting in this particular paper was we chose these particular mutations, troponin T mutations, simply because there is a very, very different type of treatment depending on where you have this mutation. For example, what we found is the troponin T is part of the troponin complex. And that complex is part of a huge subcomplex of the thin filament, the actual filaments that are the ores when muscle contraction takes place. So it's a vital component of that. But within that, some people are getting electrical problems like Christian Erikson. Other people are getting just heart failure, as if they've had an enlarged heart and without any electrical problems initially. The treatment for this, very different. Very different. And what was worse, you couldn't pick it up early. So if you did an echocardiogram and you think, well, what's causing this electrical problem? It must be because I've got an enlarged heart. Not in this case. So there was no early physiological sign for us to say it's going to happen or it is likely to occur. It seemed to come on in a mechanism that we weren't quite clear on, but we knew there was some genetics going on. And so what was interesting about this was when we looked at it, and I was looking into the whole process of the structural biology of this, we were very surprised to see that actually there was not much on the actual interactions because we don't have the full crystallized structure of these. So we couldn't just say this protein is going to attach to another protein. They have this intermolecular interaction based on that because we didn't have that data. So we had to start from the ground up. And this is why I'm particularly proud of this paper and the way that it actually showcases multidisciplinary teams coming together. Strong scientific hypothesis-driven work. We didn't go on a fishing exercise here. We basically took step-by-step means to understand how do you work out based on the structure of a protein, what the other likely interaction would be. We have homology studies from other species. Can we use that? Can we then also use that fact of having a molecular dynamics? So we did testing of that. All of that put together, we then added the clinical data from around the world. So it was the model first, then the clinical data.
So talk us through then this computer model.
I urge people to read the paper, because that first figure 1 is a summary of how a dynamic system and model we built, which is to understand that in the face of a beating heart system, which requires calcium to come in, what we found is that you have particular interactions that are due to calcium, and those regions within the gene itself highlight areas of different clinical phenotypes, but also clinical outcomes. Okay.
Yeah.
And those regions or areas are actually very discrete and very independent of any other model that we've seen thus far. So it gives us now, hands up, at the moment, what happens in sort of the whole spectrum. You go and see a clinical geneticist and they say, okay, we've got the mutation, you've got this variation, go and see the cardiologist. What I wanted to do is to make this more of a smooth precision cardiology, precision medicine clinic, where you'd not only have 2 distinct areas, you'd speak to the geneticist, the genomics, and the clinicians, as well as the scientists, to say, look, we can get a plan for you because we know the extent of where the mutation is. We know what are the implications are of some of these mutations. So that would give us a heads up to say, should we be thinking about specific therapies similar to putting defibrillators in? Should we be thinking about giving tablets? And how that plays out as that patient moves forward.
But you were saying earlier that you don't always know from symptoms that someone could suffer from this. So should we be screening everyone? Should we be plugging everyone's genetic data into this computerized system and seeing if there's any possibility it could occur, and then treating?
The current screening methodologies are based on risk, right? So what we're doing now, and what a lot of people do, if there's a family history, or if there's someone's collapsed in the family, or there's a history of heart problems in the family, you get screened that way. So we do a sort of like a pedigree screen, mom, dad, uncles, etc. So you get to build a picture. What's interesting now and what's exciting moving forward is this whole genomic space that we've got going on, where we're sequencing initially 10,000, now 100,000 people. We're getting a lot of data to understand what are the early factors or early potential markers. We don't know the implication of that in real world, clinical world, because we can't go around saying, look, we'll put this device in before it happens. Because that's not the premise of what we're doing clinically. The premise of something doing clinically is it should be symptom-led. But in the genetics world, this, I think, is a bigger debate for everyone, science and society, to understand that now that we're getting slowly into a state where we can have better understanding of data, and we're getting to the whole notion, and we talk about this in the paper, about prognosticating data, predictive analytics, as they're called. Where does it end? When do you draw a line for patients who then say, look, I had a test privately and I know that this is something that could happen. Can you put a device in? Can you put treatment? What we're saying is that is not the way forward. The way forward is to be better aware, so you can risk stratify people to say, look, if you have this mutation, maybe instead of seeing you every year, maybe you see you 6 months, or maybe we put on specific devices to see, which we would have otherwise seen, put monitors like Holter monitors, so we can measure electrical outputs that you otherwise would have met. So it's trying to get ahead of the disease state in all cases. But what I'm really proud of this and the way we've done this is to take it from the ground up, use the biology, understand the biology, and not put any sort of random extrapolation to say, look, this should be the next best thing since sliced bread. What I'm saying is this is something that has really helped us to understand and integrate a lot of data. And this should be maybe a possibility for others and other groups to try and use and assimilate data rather than just come up with more and more data without really trying to understand how it all fits together in a complex system.
And what's next? What's going to be your next project along these lines?
So that project took us a bit of time. Happy that the Wellcome Trust allowed us to fund that. What we have done, we've extended that, and over the last few years, we have actually looked at specific therapies, what I would call precision therapeutics, drugs designed for that particular variation mutation. And we have currently produced a drug, and it has gone through clinical trials. That is something that we're hoping to actually publish fairly soon, because we've got a real strong idea on the mechanism of how this particular variation affects the underlying biology and signaling within the heart cell. And so we were able to thwart some of the clinical symptoms that can occur as a result. So that's the next exciting thing that we have coming up soon.
I'd be interested to know in the kind of the potential tangible outcomes of this new kind of precision therapy. I mean, what could patients potentially be seeing in the future there?
So a great question, Rob. One of the things that we're seeing is, if you look at the cystic fibrosis world, the company Vertex have had FDA approval for specific genotypes of cystic fibrosis, not as a cure, but as symptom reduction in the whole output for cystic fibrosis. And what I'm viewing this as is, currently, if you look at the way we're prescribing medication, it looks at the body in a very much linear system-led view. You've got a problem with the heart, here's a tablet for the heart, the system is in the heart. You've got a problem in your lungs, so you treat the lung problem. But we all know it's a multi-systemic problem. It's a system-wide issue. The biology doesn't stop in one organ. It's working throughout the whole of that. This, I think, is where we're looking at these precision therapeutics, whereby we have found and we were able to repurpose drugs that you would have thought, oh, what's that got to do with heart disease? But the biology and signaling of those particular small drug or small molecule-based systems actually affect not just gene transcription and signaling, but have an effect right the way through, whilst also trying to keep the side effects of drugs down. So what I mean by precision therapeutics is saying, if we have a problem in a particular variation or mutation, that sets off a whole cascade of signals that can lead on to what we see clinically. And what we're trying to get to a stage, and what I'm hopeful, is to say, why are we waiting for the signaling to come to such a big array where we're trying to reverse a problem that began? Why can we not go back to the problem? So aspects of gene therapy, people are looking on it using sort of gene therapy as a means to go back to the gene problem. But the issue I have with gene therapy is, it's not just one problem sets off the thing. It's a multitude. So it's almost like the Jack in a Box, where you drop one and it comes out, drop one and it comes out. So we are trying to get over the whole space of saying, how do we precisely affect signaling, but also not affect outside organs and outside side effects?
Fantastic. Thank you very much, Rameen. So now I'm going to hand you over to Jordan for our final section of the podcast, the quickfire round.
Okay, excellent. Thanks, Rob. So we've got some quickfire questions for you. So the first question is, what are the 3 skill sets you need to get into this area of precision medicine?
So 3 biggest skill sets, I would say, is strong grounding in genetics, an inquisitive mindset, and a long, determined personality, because you'll get a lot of failed experiments before you get to the right ones.
Ah, excellent. So I've got a list of 5 of the most common habits we might associate with causing diseases in the heart.
Okay.
And I just want you to tell me what you think would be the worst one or the most risky of the habits. So we've got drinking alcohol, drinking coffee and energy drinks high in caffeine, eating junk food or foods high in sugar, salts and fats, over-exercising and smoking. Which one of those is the most risky to your heart health?
So the number one would be smoking.
Right? Why is that?
So you've got smoke, and it is because the effect of smoking is so diverse. It impinges on all aspects of the physiology of the heart, not just increasing risk of flaring up atherosclerosis of the coronary arteries. It also increases the arterial stiffness, increases risk of not just cancer, but the whole gambit for cardiovascular disease is actually much, much higher for smoking than any of the others. Well, then I would probably say quickly followed by the whole epidemic of overeating, obesity, as well as sort of alcohol. Now, I put alcohol and overeating together because essentially when you're drinking a lot of alcohol, if you think about it, you're essentially having a lot of fat in another term, because it's calorific liquid is what you're having. So if you have high calorific of anything and you don't burn it off, that's the whole effect of obesity, and everything in moderation will negate that. But out of everything what you've said, I would put smoking as the one thing that if you can stop, that would have the most tangible, real world effect in reducing cardiovascular risk, and fairly quickly.
And the next sentence is, the one development in cardiovascular medicine I'm most excited about right now is?
The one development in cardiovascular medicine that I'm most excited about is the aspect of genome editing and application of genome editing in cardiovascular disease for not just modeling cardiovascular diseases, but also looking to translate that in the clinic.
Thanks for joining us all the way from across the pond. So welcome to this month's LabLife. This month we're joined by Francis Yongblah. He's a laboratory manager in microbiology and virology at Great Ormond Street Hospital for Children. Outside of his work, he's a keen musician and is studying for a PhD sponsored by the Antimicrobial Resistance Initiative Precision AMR. Welcome to the podcast, Francis. Thanks for joining us today.
Hi, Jordan. Thank you for having me.
So you're a keen musician and you've actually done some work with the London Gay Symphony Orchestra.
Yeah.
So can you tell us then how you started with music? Has this always been a passion of yours? Where did this begin?
Yeah, sure. I will always remember. I think I was about 11 years old at high school, and I just saw one of my friends actually playing the piano, and it was that moment I was completely engaged. So I said to her, "Oh, could you give me your teacher's contact details?" And at that point, I started lessons, and then it just kind of flew. So I started piano, and then following that, I also took up the saxophone as well. And at 16 years old, I decided, you know what, I really want to take up the violin. So, and then when I got into university, that was really key, because then they had a society, one of my passions at university while studying biomedical science. So I participated in the orchestra, and we had different members, from different courses joining. And that was really great. There was the orchestra, there was a jazz band, and I just loved it. I mean, the social aspect as well, but just making music. And then actually, friends from university who lived in the Essex area contacted me about actually starting a jazz band group. So this started in Essex, in Chelmsford, and we formed a group called the Jazzles, kind of using Essex technical terms. But it was a really, really good group to be with, because we were all from different backgrounds, did different jobs. It was something just to kind of escape work as well, because we made like really good music. And then actually we eventually started playing at different events, and it was just so enjoyable, and like we got such good responses from people.
How did you become involved with the London Gay Orchestra? Can you tell me a little bit more about that?
So I guess I still wanted to play with an orchestra, like a larger orchestra, because I've never actually done that. It was always a small orchestra. So I kind of speaking to different people, and a friend said, "Oh, have you looked at the London Gay Symphony Orchestra?" And I thought, "Oh no, I've not heard of them." So I went to go listen to them play. Oh my goodness, they had a concert. It was just, I was just sat in the church. It was phenomenal. The music, they were amazing.
Yeah, they're really talented.
Yeah, very talented. The musicians there, I mean, some of them are professional musicians. Some do completely different jobs. There's people from different backgrounds. It's amazing. And they're so welcoming. So once I heard them play, I was like, right, that's it. I need to join for the musical skills, but also to mix with the group. I mean, it's a mixed, diverse group. Again, it's an LGBT group, but also it's inclusive. That lots of other people are welcome to join and make music. And it's a friendly, opening group. And they really welcomed me. And I felt so comfortable. We had a great time, and I also got involved with the committee there as well. So I was social secretary and managed to create a lot of events. So, a lot of socials trying to advertise our concerts. We actually bumped into Gok one evening. That was a really awesome, and we got free champagne. But yeah, one company was in a bar that we were in when we were advertising, and they just bought us all champagne. It was amazing. I've had some great opportunities with the orchestra too. So we were actually on BBC Three, and we were involved in a competition, which was the Great British Orchestra competition. So that was really amazing opportunity because it was just to showcase the orchestra and what they do. We've got to travel as well, so we've been abroad. We've performed in Paris and Amsterdam, so we were there for their Pride as well. So it was just nice to be with the orchestra, as making music, but also socially too, and just to celebrate Pride. It was awesome event. So I love the orchestra. They're just so welcoming. It's like a family, and it's just nice to have something. I love my job as a scientist and manager, but then also at the same time you need something to escape. And I think having that opportunity to make music with people who you see as like family and friends is lovely. And they're just amazing. And I it's been a really tough time during COVID as well. So I mean, the orchestra are now coming back together at the moment. So it's hopefully things are getting a bit back to normal and they can starting to make some music again.
So you mentioned Pride, and I wanted to ask you about this, as we've just had Pride Month, and I know you've taken quite an active role in making sure biomedical scientists are represented at London Pride previously. So how important is it that biomedical scientists are represented at Pride? And what more can be done to promote equality and dispel discrimination across the profession?
Yeah, I think there's work to be done. I think sometimes people think, oh, is there? But it really is. I mean, when I started my career out as a biomedical scientist, as a trainee, I'd actually seen homophobia in the workplace, prejudice. And it was really, I mean, I've experienced it too. And I was really kind of fearful in the sense that I thought, because of my characteristic, because as a gay man, I thought, am I going to be discriminated? Will I not have that opportunity to, for my career to develop? But I've worked hard, and I think it's important for people to represent, and have equality, because people can bring so much. So I think, I think in the past there hasn't been much in terms of the IBMS or the profession actually moving, Pride forward and kind of representing LGBTQ, because I think it's not ever discussed about, but I think it's quite a key issue. But I think more is happening. So, I mean, there are hopes that actually the IBMS will march in London Pride this year. Fingers crossed, we're waiting to hear. But I think just kind of representation that there are, LGBTQ scientists as part of the workforce who contribute, who really bring, a lot to the profession. And I think it's key that we represent them and that they, everyone has a fair opportunity.
What kind of stuff have you been doing to mark Pride Month?
So at Gosh, we've been doing a number of kind of meetings, panel meetings, social distance events, trying to meet up. And just kind of representation on social media as well, just to make awareness. I think there's still a need for Pride, for people to be represented. So we're hoping London Pride will go ahead in September. Engaging with people just to realise that there are, within the healthcare scientist workforce, there are LGBTQ members of staff there.
Absolutely. So I just wanted to touch on your PhD and some of the work you've been doing recently around this issue of antimicrobial resistance. So your PhD is funded by the Precision AMR Initiative and is helping to combat resistance to antibiotics. And so I know you've recently also been involved in this new Rise of the Resistance Festival, which is dedicated to just this issue. So could you tell us a little bit more about Precision AMR and some of the talks and performances that took place at this new event?
Yeah. So Precision AMR is a huge grant that's been given by the government it's an initiative to basically improve antimicrobial prescribing and just, the issues with AMR. So basically as part of it, we had a virtual festival, and that is basically to try and engage and raise awareness of the issue of AMR. And it's doing it through different events, so such as like panels, where there's discussion panels discussing different things that are not even discussed about. I mean, we talked about how do we engage with hard to reach people, and that was quite an interesting topic area, because what do you mean by hard to reach? But I mean, raising awareness of AMR to everyone, from like patients, parents, staff, just to get it out there. And I mean, we also try to use other means of engagement, so using the arts, so through kind of like a play or a comedy, through shows. And that they are kind of key ways to engage with people, because people like to watch shows or see a comedy. There was even a drag show about someone called Klebsiella. So yeah, having that kind of engagement to actually make people aware. Also a sock puppet show. And it's just a way of trying to get that information across, because sometimes you can just talk to someone. Does it actually go in? Does that information go in? And I think using a different means of trying to engage and communicate is really, really key in order for things to go across. And so I think if you can drive that message through, then that's key. So the Rise of Resistance Festival was really a big initiative just to engage with, clinicians, NHS staff, healthcare science staff, the public, and trying raising that awareness. And I mean, there was, it was kind of going off on Twitter. There was a lot on social media trying to get people to come to these events so that actually they engage with what is happening. Because I think, within healthcare science, there has been a big focus on COVID, but I think we do need to remember there are other things that are going on in other disciplines. And so I think it's really key to remember that too. So
what's the reaction been to the event?
I think it's been very well received. I think people have really enjoyed it. I think they've learned a lot, and I think it's definitely made people think. I mean, even myself, even though getting involved with it, having those panel discussions made me think, because we talked about engagement with people and actually making people aware, like, oh, this is happening. And so actually, yeah, I think it's been very well received. And I think I'm hoping that the message is going through, and I think we will definitely be doing it more. Those videos and shows are still available online.
Thanks to Francis for joining us on this edition of LabLife, and check out our show notes and the podcast blog on our website for more information about the work he does, and to check out some of those performances from the Rise of the Resistance Festival.
Thanks so much for listening. We hope you enjoyed the episode. These podcasts are released monthly at the same time the magazine comes out, so whenever a new issue lands on your doormat, head back online to listen to a new episode. And don't forget that these podcasts can be used for your CPD. Take care and bye.